Okay, welcome back. I have set up what's going to be a parallel circuit, and right now it's operating, but only in a series because we don't have the connection made here and here. If you recall, when we had one light bulb and then we added a second light bulb, the voltage went from like a 9-volt drop in the first light bulb, and then we added a second light bulb, so it had to share that 9 volts, so it ended up being 4.5 and 4.5 volts. So what does that do to the brightness? Well, it would half the brightness as well. So it wouldn't be, the light bulb wouldn't be as bright when you've got a light bulb in series, one after the other. That's only going to be for every new light bulb you put on, the brightness goes down. Now I want you to observe the difference here in parallel. Okay, so if I make the connection here, and just observe the amount of brightness here, and does it go down when I make that connection? No, it doesn't. And does it go down here? No, it doesn't. And that's because in parallel, if you remember, that current isn't consistent. It isn't going to be the same, and that's shown here because take a look how slow these electrons are moving compared to how quickly they're moving over here. Right? They're going very, very slow here, and they're going quickly over here. If you were to take a voltmeter and measure, I'll just put it here, and measure each side of this light, it'll come up at 9 volts. And that's because our battery here is set at 9 volts. And if I go on to the next one, it as well will show up as 9 volts, and this as well will show up as 9 volts. Okay, that's what like in parallel we've got voltage equals voltage equals voltage, and it's the current that changes depending on the resistors and that sort of thing. So keep that in mind. Now some of you may be asking, though, why is this negative there? Well, just take a look here. If I just happen to be doing it the same way each time, but if I put the red one on that side and then the black one on this side, we end up with a positive. So it's really the numerical value that we're interested in on these. So keep that in mind, and that the voltage is equal to the same across each light. Okay, so another kind of cool thing is, let's say for whatever reason this light bulb burns out. Okay, and I'll just do that by breaking this circuit. Well, what happens? Well, this light bulb then goes out, but the other light bulbs are still running. And when you go to examine your string of lights, like maybe they're Christmas lights or something like that, you'll see exactly which bulb it is that went out. When they're in series, if one light bulb goes out, then they all go out. And that makes it really difficult to figure out which one was giving you the problem. You actually have to take each of them out and put the next one, put a good one in, and if that fixed it, probably didn't. If it was anything like me, it was like the almost the very last one that I checked was the one that was having the issue. So, but with parallel, you'll know exactly which one. Okay, so in reality, what they commonly do for Christmas lights is they'll do a combination series parallel. So they'll have a big string of lights, and they'll have it divided up into 3 sections, and the sections each will be in series, but within each other, but it would be in parallel to the others. Now, it sounds a little complicated, but basically what it does is if one of the light bulbs goes, then that whole section goes out, but at least you've reduced how many you have to check. Okay, so that would be the same idea as if I put lights along here. So that you consider these 3 different sections, and I grab another light bulb, and I'll just sort of rotate it around here, and I connect it here, grab another wire, and make the connection here. Okay, now if one of these light bulbs goes out, and I'll just imitate that by breaking this, then these 2 go out, but these 2 are still on. Okay, All right, now I'll reconnect this, and I want you to take a look at the brightness of these two. The yellow lines in here for these two in series are nowhere near as bright. Okay, because they're in series, they have to share that 9 volts, and I'll show that to you by doing this. We've got on one side, and then the other side we can make the connection 4.5 volts off across that one, and then 9 volts if I'm looking at both, and 4.5 for this one down here. So they have to share that 9 volts. In that way, these bulbs wouldn't be as bright as this one here or that one over here. So that's a little tour around some ideas behind parallel circuits.